Hey everyone, welcome to our webinar. The topic today is how to use Kafka to move from batch to real-time processing. And we are going to show you that using a real case out of the finance world. And we have built a little application that shows how to leverage Kafka features in order to have a real-time reporting on our portfolio, stocks portfolio. The agenda for today is first, I'm going to introduce a little bit the business case, explain you what we are going to show you in later on in the demo. Then my colleague Pavel is going to show you the application and explain a little bit the architecture behind this application. And after that, we will have some more information regarding Confluent and Mimacom. So we are always talking about real-time streaming of data. A good example, in our opinion, of real-time streaming is comes out of the banking sector, and it's basically stock data streams. So we have different stock exchanges around the world, and when they are open, they actually send all the time new values of the stocks. The time when the events or the new values of the stocks are sent are not known. So it's really a stream that delivers us the information once the information is available. The idea here we had is to say, okay, let's take a stream of stocks from the outside world. So it could be any source. Maybe some of the most known are Bloomberg and Reuters, but there are also other fintech that provide such data, and combine that together with the information we could stream out of a core banking. So basically we would have these two streams here. On the top, we would have the values, the current values of the ABB stock, for example. And on the core banking side, what we would do is stream all the changes and basically all the transactions happening on the core banking side. There we would know, okay, some user is buying 100 ABB stocks or selling 300 ABB stocks and so on. And what we want to do, or what we're going to show you later on, is how to combine the number of stocks a given customer has in a bank with the current value, and show that on a time series to see how the performance is moving throughout the day, and also in real time, so without delay, without batches. What's nice here is we can do that with very little programming features, because Kafka and the Confluent platforms offer so-called CDC, change data capture plugins, where we can easily connect to a database or for the stocks over some HTTP API, and then get the data mostly in real time. A good thing also is, maybe as you know, the core banking system has a lot of tables, a lot of data, and we don't need to actually replicate all the data of the core banking. There we can very easily say, okay, we are only interested in these 4 or 5 tables where we have the information about the transactions customers are doing on the core banking platform. Plus, of course, we would replicate the permissions so that we know what the user can see and what he's not allowed to see. Exactly. So that's the use case we prepared. Of course, we are very focused here on the real-time part. But what we are not going to dive into today, but what's also interesting is the whole compliance and the regulatory part. Because once we have all these events here, we can also easily actually show an audit trail with every action that happened on the system. But as I said, that's out of scope for today, and we would like to dive into this real-time part. So now I would like to pass the word to my colleague, Pavel, who's going to show you the application.
Hello, everyone. Thanks, Alan. So let me show you in more details what we are about to do. And first, let me just depict the idea we had. So the project we are about to kick off focuses on financial products, their management, some characteristics, and definitely its temporal evolution, and provides a lot of additional computed characteristics to it. However, for the sake of this meeting, we will focus only on the near real-time processing and how we can utilize Kafka landscape exactly for that. And because of the scope, we won't be talking much about the features that are otherwise extremely important for finance, as such as machine learning for forecasting and more sophisticated financial algorithms. However, the way we want to ingest real-time data may apply to historical data as well. So we see Kafka as a primary source of truth in our system. That means we can apply the same infrastructure, the same things we use for real-time processing for historical data as well. All that has to be done is to ingest this historical data, if they are not already ingested, into Kafka topic and process them as usual. This is more or less what is defined in Kappa architecture. I won't be talking about data at rest, and the security part of this will be only mentioned briefly during the presentation of the slides. So let me start where Alan stopped. The central part, of course, is Kafka, and for data ingestion, we see that all our needs are fulfilled by wide spectrum of Kafka connectors. We can ingest data from existing databases. We can use queries for that. We can use change data capture approach. We can ingest data from available services, online services via HTTP polling, other server-side events. These data land up through Kafka connectors in our Kafka topics and are fed continuously. That means the data flow is continuous, happens in the background, and it's completely decoupled from the next thing we leverage, and that is KSQL DB or Streams API from Kafka, which is used for data processing. Here we need to calculate few things. As you know, in classical finance area, a lot is calculated based on what happened. Risks, returns, forecasting, it all is calculated based on what already happened in the past or what happens just right now. Risk, volatility, returns of your funds, stocks, securities, yields, and any kind of ratio you would like to calculate, or even more complicated formulas like Black-Scholes formulas for derivative pricing can be done really in this layer using KSQL DB or Streams API. We found it extremely useful to prepare a common function as user-defined functions which can be used directly in your KSQL queries. For that, we see huge advantage when we provide a user-defined function which calculates standard deviations, which calculates, which applies lineage characteristic to your data. It can be used for flattening of data. You have to remember there are a lot of incoming sources which differ in the structure, and having this base of already prepared functions easy to be used in your queries in KSQLDB simplifies the data processing of this value, of this characteristics greatly. Let me move to the next slide. After we have data already landed in Kafka, after we already supplied additional information, calculate all possible characteristics, we can make it available for our consumers. And we plan on doing that with proxying. That means there will be some consumers exposed as an application which provide graphs, which provide all other things to the end user. With this layer, we can make sure the data reach the user which is allowed to see it. So with proxying, with proxy services in this part, we can apply our security needs as well. The data are transmitted to the end user via a stream, so the near real-time processing is, of course, already seen by the user. To summarize, on the left you see Kafka Connect, which completely fulfills our needs to ingest data. In the middle, there is KSQLDB and Streams API, which helps us a lot to calculate all the metrics for financial products. And on the right, you can see depiction of graphs, which are provided to the end user. In the middle, we plan on dividing Kafka into namespaces or areas. And you can see ingestion topic on the left is used to hold data and from external sources. The middle part will be used for computation. This is where the magic happens, where KSQLDB queries run, where Streams API do their job. And having these topics, we are sure we have all the metrics the user could possibly want. And the final outcomes layer on the right makes sure we have topics which are prepared for the end user and which have the information about the lineage of the data, about the source of the data, where we can apply with some additional redundancy all other security requirements, just to make sure our Kafka infrastructure is multi-tenant. Now let me show you a demo, and for that I switch the screen. We prepared some demo how this particular part may look like, what can be done with what we already have, and how, and I would try to convince you it's extremely easy to supply additional features, additional computation, just using the standard Confluent and Kafka components. Here on the home side, you see some metrics related to what you already invested. This one user, what he's already invested. He has 8 funds. he has multiple assets distributed among these 8 funds. He already invested 8,601, let's say, Swiss francs, and the actual value of what's invested is right now 1 franc less, or now it's the same, or he lost 2 francs. So you can see the values change in real time, and this happens because we ingest in the background some data from external sources related to the values of these assets. You can see Apple here, somewhere IBM, and Facebook, and with that happened in the background, we can calculate immediately, for example, the actual value of what's been invested. On the left side, there is a portfolio composition. So the most has been invested in AMD, more than 17%, and not that much in NL. This is NL Engineering or some other company, only less than 5%. On the right side, you can see the current value composition of this fund. So what has changed since the beginning? And as the funds defined here are pretty not that old, the values didn't change much. So you can see the moving parts here. But anyway, in the real case, this will be the case that the values will be continuously updated. Now, your funds look like that. Here you have the composition of all your funds, 8 in that case, and you can see there is some fund named Energy, which has 1,000 francs invested initially into a fuel cell, for example, company, almost 60%, NL and GNUs. And the current value of this fund changes in real time here on the right side. And all other funds show the same information, the composition into unique assets, current and initial value. Let's see what happens with the single fund. Apart from what's already been seen, the actual value, initial value, we calculate some few additional things. And just as a reminder, you will see some things related to risks or some things related to standard deviation. This is because in the classical finance, the risk leverages the standard deviation of variance or volatility of the financial product. So we use some stream formula for standard deviation calculation. It happens in the background. And with that, we can see that the risk based on volatility of this financial product has this value. It's a unitless value, which basically says how much risk units you will have to account for when you would like to have 1 unit of return. So if this value is negative, that means there is a continuous growth of this financial product. If it grows too high, maybe this product will be too risky for you. Initial portfolio decomposition, this is the value decomposition as it was at the beginning of this financial product, and the value composition as it looks right now. You see small changes here. It's because the values do not differ that much, but what happens in the with time, you can see on these graphs. So here you can see the 2 assets, 2 securities, which are part of this fund in this case, and their values differ from second to the next second, but not that much. This is the Apple, this is the IBM values, and the whole value of your fund oscillates around 100 francs you invested at the beginning. So current value and unique assets value, which compose your fund. At the bottom, you see some metrics related to the risk. Risk I mentioned already. This is risk to return ratio. This is the coefficients which lets you decide or whether this particular investment fund is risky or not. You would like, this is the unitless metric, so you would like to have it as low as possible, meaning there is not much risk per unit of return over this fund. On the right side, you can see the ordinary standard deviation of returns over time of this financial product. As said, standard deviation is the basis for calculation all the risks metrics in financial products, and this is what you can see here on the right. It oscillates not that much, it is more or less stable. So with this stability, you would like to have growth of your single assets to make your fund profitable. With that, we wanted to show you what metrics are possible to show, to provide. And you have to trust me, it's really easy to implement them using KSQL queries and user-defined function. This is what happens for the standard deviation. As for standard deviation, we use Welford formula, which makes it possible to calculate standard deviation of data of a streaming pipe. And the same things that are used to show you or to calculate these real-time values may be applied to historical data, as previously said. All it takes is to ingest historical data into already existing Kafka infrastructure, let it run, and then have the final results presented. But the user-defined function, queries, and streams API application remain the same. So this is where we see the huge advantage of Confluent components. Thanks, Alan.
Yes, thank you, Pavel. So let me take over. Well, to conclude this webinar, I would like to mention that Mimacom is partner of Confluent, and as partner we also provide trainings. So if you are interested to have a deep dive into Kafka technologies or around the Confluent platform, don't hesitate to go to our website, go.mimacom.com/training, where you can see all upcoming trainings and book them. We provide trainings in Switzerland, Germany, and Spain. So we are quite broad here in Europe. And also, if you would like to have more information from a project perspective, you can also go on our website and find our contact details to get in touch with us. Well, that was it from our side. So thanks for watching this webinar. And really, we like to be engaged and discuss with other people, other companies who think about using Kafka or are already using it and need some support. And we are eager to get in touch with you. Yeah, thanks and have a nice day.
Thank you.